All right, so looking at that, unknown sides. If we have a right triangle, there's two ways to find unknown sides. What's one way? Anyone? What's one way? I thought you were going to raise your hand. What's one way, Petra? SOHCAHTOA. Yeah, what's another way? What's another way I can find unknown sides? Pythagorean theorem. Now, to be able to use Pythagorean theorem, you have to have how many sides? 2. And in this triangle, do I have 2 of the sides? No, so I would have to use SOHCAHTOA, okay? Now, before I do that, if I want to find angle measures, what's one way I can use angle measures? Or find SOHCAHTOA again. And how would I apply SOHCAHTOA to angles? The inverse. I'd have to use the inverse that we just talked about in 4.7. What's the other way? It's another way to find missing angle measures out of a triangle. 180 minus the other angles, right? Yeah. All right. So looking at this, if I want to use SOHCAHTOA, again, I have to have 2 side lengths, right? For me to use the 180 minus whatever the angles are, I'd have to have 2 of the angle measures, right? So let's do angles first in this case. Am I going to use SOHCAHTOA to find the missing angle of B, or can I use the 180 minus the angles? 180. So the measure of angle B is going to be 180 minus, what's my 2 angles? Okay, 124, or could I just do 90 minus 34.2? Yeah. Okay. So the measure of angle B is equal to what? $55.8 degrees. What did you say, Anthony? Oh, that's all right. Anyhow. All right. Now, looking at the missing side lengths, okay, let's go ahead and find A first. Here's my angle. The A side is known as the opposite, and the B side that's given is my adjacent. So what uses opposite and adjacent? Tangent. So the tangent of my angle, what's my angle? 34.2 is equal to my opposite, which is A, over my adjacent, which is 19.4. And I like putting the tangent over 1 because now how do I solve for A? Cross multiply. So A will equal 19.4 times the tangent of 34.2. Okay. So A is approximately, let's go ahead and round to the 100th. Now, remember, 34.2 is in what? Degrees or radians? Degrees. So your calculator needs to be in degrees. 100th. And what did we get? All right. Now, when I go to find C here, okay, do I want to use the side of A? No. Why? Because I rounded A, right? If I'm going to use A, I would actually have to use the exact answer of 19.4 times the tangent of 34.2. That sounds more confusing, doesn't it? So let's go ahead and find C using our B. So B again is my adjacent side. And then what is C? My hypotenuse. So what uses adjacent and hypotenuse? Cosine. So the cosine of my angle, which is 34.2, is equal to my adjacent, which is 19.4, over my hypotenuse, which is C. Now, how do I cross multiply here? Right, so I'd have C times the cosine of 34.2 equals 19.4. But then as we said, to solve for C, you would divide by the cosine of 34.2. So C would be approximately 19.4 divided by the cosine of 34.2, which is 23.4. Right. Any questions with that? Right, the height of a mountain is 5,000 feet. So from the ground to mountain peak A is 5,000 feet. Okay, you guys okay with that? All right, the distance between the peak of that and of an adjacent mountain is 25,000 feet. So from peak A to peak B, that is 25,000 feet. Okay. The angle of elevation. So angle of elevation has to be formed from what kind of line? Horizontal.
Angle of elevation is perpendicular line.
Right. Oh, an angle of elevation is an angle formed from a horizontal line, right? So from peak A, we have this horizontal line, and then looking up to peak B, that is 27 degrees. Okay. Now, what is the height of the adjacent mountain? Okay, what is the height of my adjacent mountain? Now remember, this angle of elevation is from my horizontal line looking up to the peaks, to both of the peaks, right? Now, if I draw a line from peak B to C, I do form a right triangle. And I can find the missing side length there, right? But my question to you is, if I find A, is that actually the height of my mountain? No, I would have to then, once I find A, add the 5,000 feet so that I can actually get the height of it from the ground all the way up to peak B, right? So let's go ahead and find what A is. From my horizontal line to the peak, how high is that? Okay. So let's think about this. From 27, my A is what side? Opposite. And the 25,000 is my hypotenuse. So what uses opposite and hypotenuse? So the sine of my angle, which is 27 degrees, is equal to my opposite over my hypotenuse, which is 25,000. Okay. Cross multiply. So A is going to equal 25,000 times the sine of 27 degrees. And I don't know why I put a parenthesis there. So A is approximately what? Now let's go ahead and round to the nearest foot, since everything else is to the foot. So what did you guys get when you round to the nearest foot? 11,350 feet. So we know from C, from the top of A to the peak of B is 11,350. Now, how much is it for the actual mountain? What would I need to do? Add the 5,000. So we get 16,350 feet is the height of mountain B. Okay. Any questions with that one? Okay. All right. At a point, yep. Huh? Are you being a tattletale?
You really think
Guess what? Who gets his stuff done? Yeah. All right. At a point 200 feet from the base of a building, the angle of elevation to the bottom of a smokestack is 35 degrees. Okay. So the point 200 feet from the base of the building. So my base of the building out is 200 feet. Okay. Now, the angle of elevation, since that base is 200 feet, that is a horizontal line, right? If I'm looking at an angle of elevation, that means I'm looking upwards to the bottom of the smokestack. So the bottom of the smokestack would be here. So we know this angle right there is 35 degrees. Okay. So we have a right triangle right here. So we can find the height of the building just from this information, couldn't I? Yeah, okay. Now, whereas the angle of elevation to the top is 53 degrees. So if I look up and I actually look to the top of my smokestack, that whole angle there is 53 degrees. So wouldn't we have another triangle here? Yeah. So I can actually then find the height of my entire building, right? So from both of these triangles, I can find A, the height of the building. I can also then find the height of my entire building, right? And if I know the height of my entire building, could I then just find the height S of my smokestack alone? Yeah, because how could I then do that? Subtract the two, right? But I'm going to show you a different way to kind of do that one here in a second. Okay. All right, let's go ahead and find the height of the building. Let's find A. So from 35 degrees, the A is my opposite. So this whole side of my triangle is going to be opposite, right? And the 200 will be my adjacent. So I'm going to be using what trig function this whole time? Tangent, okay? So the tangent of my angle, what's my angle? 35 is equal to the building height, which is A, over my adjacent, my distance away from the building, which is 200 feet. Okay. So A is found by taking 200 times the tangent of 35. Okay. So what do you guys approximately get for my height of the building? Let's go ahead and round to the nearest foot. Let's do the nearest foot. So 140 feet. Okay. So remember, 140 is an estimate. This 200 tan 35, isn't that my exact? So my exact and my approximate. You guys okay with that? All right. So now if I'm going to use A again, am I going to use my exact value or my approximate value? My exact value. Because you're using a calculator, so could I retype this in if I really wanted to? Yeah. All right. So now let's go ahead and find the height of the building with my smokestack. Am I still using tangent? Yeah. So my tangent of now, what's my angle? 53 would equal my opposite side. What is my opposite side? How would I get the opposite side? You could name it X. Yeah, we could do that. Or could I just do A plus S? Would that be okay? Yeah, and I'll show you why in a second. And then divided by what's my adjacent? Okay. So now cross multiply, right? So when I get the 200 tan 53 is equal to A plus S. You guys okay with that? Now, we could use our calculator right now, but I'm going to wait a second. I really want to know, what are we trying to find? The height of the smokestack, which is just what? S. So how could I move A to the other side? Couldn't I just subtract it? So couldn't I take 200 tan 30 or 53 minus A would equal my S? Well, do we know what A is? Yeah, so could I substitute what A is? Yeah, what is the exact answer for A? What is my exact answer for A? 200 tan 35. And that would equal my S. So what is S approximately to the nearest foot? 120 feet. Huh? 125 feet. Yep. Now, again, yes, you could have labeled this as X, and then you would have to take X, whatever you get, and subtract it from the A, or A subtracted from that. All right, any questions so far? All right, a swimming pool is 200 meters long and 12 meters wide. Okay, the bottom of the pool is slanted, so the water depth is 1.3 meters at the shallow end and 4 meters at the deep end. Okay. Find the angle of depression of the bottom of the pool. Angle of depression means what? We are looking down, right? So we're looking down in the sense from a horizontal line, right? So real quick, my angle of depression is going to be, or that slant is going to be the slant of my going to the deep end, right? It will start when the slant is with our horizontal line here, right? Well, how long is my pool? What do we say? 20 meters, right? We want to find this angle here. Now, if you look, they gave me a 2.7 here. Do we know where 2.7 came from? Right, so if we know, they gave us 1.3 and 2.7. They gave us 1.3 here, and it said that is at the shallow end. So when I first get in the shallow end, from the top of the water to the shallow end is 1.3 meters. Then it said, and it's 4 meters at the deep end. So at the top of the water, all the way down to the deep end is 4 meters. But does that slant start at the top of my pool? No, it starts where? At the horizontal line. So that's where we took off. That's where that 2.7 came from taking 4 minus 2.7. Okay. So I just want to talk about that. Now we're going to look at the slant kind of starting where my width of my length of the pool is 20 meters. So we're still going to look at it as 20. Yeah. I know, that's what it wouldn't normally be like that. So technically, when we look at this, if we're doing this actually on from a real pool, we'd have to shorten the length of the pool because the slant doesn't start when it's 20 meters, does it? The slant probably starts when it's at, I don't know, 16 meters. Emma, do you want to tell me? Do you know that? When does it start slanting to the deep end?
I actually don't know.
Okay. I don't know either. So we're going to use the 20, okay?
All right.
All right. So now looking at this, if I want to find the angle of depression, we're going to use that 2.7. And that 2.7 is what side from that? Opposite. And what is the 20? The adjacent. So what uses opposite and adjacent? Tangent. So the tangent of my angle. Do we know my angle? No. So we'll just label it A. Equals, equals, what's my opposite? 2.7 over my adjacent, which is 20. Now, how do we get rid of tangent? We take the inverse of both sides, right? Remember, as we learned last class, the tangent, the arctan of tan is just the angle, which is A. And then what's the inverse tan of 2.7 divided by 20? And let's go ahead and round to the 100th. 7.69. What? Is that exact?
Oh, is it in radians?
Mm-hmm. Gotcha. And we got end up in degrees.
Wait, it would be in radians?
Huh?
It would be in radians?
Do you-
It would be in degrees.
Well, my final answer is in degrees.
Right, but like when you put it in the calculator.
Double check.
I think John.
Yeah,
No, I was.
I'm in degree. It's degrees. You're in degrees. So you should be in degrees because that's what we're trying to do. If we left it in radians, it would give us a radian degree. Or you can't have a radian degree, but you know radians. Huh? Second tangent. Maybe we should have a normal calculator. Oh, okay. All right. Or grab one from here.
You can buy, like the regular, like the CI ones at the, like that one, you can buy that at the.
All right. Talking about bearings here. Okay. All right. In surveying and navigation, directions can be given in bearings. A bearing is a measure. Huh? It measures the acute angle that a path or line of sight makes with a fixed north-south line. Okay. So before, remember when we talked about reference angles? Reference angles were always the angle from the x-axis to the terminal side, right? Bearings are different. It's based off of your north and south, okay? So the bearings of, if I say it's south 35 east, it's the angle from the south, so my y-axis going towards the east. So it's 35 degrees from the y-axis to that terminal side, okay? For north 80 degrees west, we go to the north, so which is the y-axis, and then we go 80 degrees west to form that terminal side, okay? Our reference angles used to be from the east to the terminal side, that x-axis, now it's from the y-axis, okay? North 45 degrees east is that degree right here. But north 45 degree east, isn't that the same as that reference angle? If we looked at it in terms of pi and stuff. Okay. What if it would be southwest? If we went south 32 degrees west, what quadrant would that be in? 3. And where would my angle be, in 1 or 2? Where would 32 degrees be, in 1 or 2? Be in 2. Why? Because we always go from the south axis, okay? So that's why it's 2 here. Does that make sense, Noah? Okay. All right. So a ship leaves port at noon and heads due west at 20 knots, or 20 nautical miles and miles per hour. At 2 p.m., the ship changes course to north 54 degrees west as shown. Okay. Find the ship's bearing and distance from port at from the port at 3 p.m. Okay. So we have a lot going on here. Okay. So we want to know, okay, the north 54 west is based off of, remember, if we're looking at our quadrant, north 54 west would be in what quadrant? 2, right? So if you're looking at here, this would be 54 degrees. Okay, so as you can see right here, that's where that comes. This dotted line is kind of like my north axis, right? This one is my east and west. You guys okay with that? Okay. All right. Now, we want to find the ship's bearings and distance from the port. Our port is down here at A. Okay? So when I want to know the ship's bearing, I am going to need to find the angle. If I draw a horizontal line here, my bearing would be based off of here. Okay, so this is the angle for my bearings. Now, as I look at this in that sense, okay, this, I can only find this angle, couldn't I? From my picture? We'll have to do a lot more work for that, but can I find this angle? And if I know this angle, could I then find the bearings? We should, right? Why? Because from the north to the west, what angle is formed? A right angle. So could I take 90 minus whatever this is to be able to find my bearings? Yes. Okay. The distance from the port is going to be C. So we need to find an angle and we need to find the side line, right? All right. So to be able to find the angle, I need to use this right triangle, right? You guys okay with that? So I need to know what this side is, the opposite side. And I also need to know probably my adjacent side, correct? Now, if you notice, we don't know any one of these sides, do I? No. But can I find my opposite side? Do we see any more right angles formed? Right triangles? Yeah, right? Because if we're looking at this line from here to here, we know it's what? 20 nautical miles, right? If I extend this to make it the x-axis and then the y-axis, right? We have a right angle, don't we? And let me ask you, if this from here to here is 54 degrees, could I find this angle here? Yeah, what's that angle? 36. Now, if I know this angle is 36, can I find my opposite side? Yeah, because I have my opposite side and I have this 20, which is the hypotenuse. So what uses opposite and hypotenuse? Fine. Okay. So the sine of my angle, what's my angle? 36 would equal my opposite, which is b, over my hypotenuse, which is 20. So solve. So isn't b equal to 20 times the sine of 36? And that's my exact answer, right? Does that really actually ask me anything about what b is? No. So do I actually need to do the math on this? No, because if I have to use b again, wouldn't I have to use my exact answer anyways? Yeah, so I'm going to go ahead and just leave it there. If you want to approximate it, go ahead. I really don't care. Okay. Now, can we, if we want to, can I find d? Yeah, how would I find d? D is known as my adjacent, correct? So what uses adjacent and hypotenuse? Cosine. So the cosine of my angle, which is 36 again, is going to be d over 20. So my d is equal to what? 20 times the cosine of 36. And now I have an exact answer for d. Now, if I know what b is, I know what d is, am I going to be able to find angle A now? Yes. And how would I find angle A? B is my opposite. Here is my adjacent. So again, I'm going to use what? What will I use there if I have an opposite and adjacent? Opposite and adjacent? Tangent, right? So I'm going to use the tangent of my angle. Do we know my angle? Do I know that angle measure? No, so I'm going to label it A. Equals. What's my opposite? B. And what is B labeled as actually? 20 sine of 36 over my adjacent side. And what's my adjacent side? Right. 20 cosine 36 plus 40, right? Now, how do I get rid of the tangent? The inverse. So I need to find A. I want the tangent inverse of all of that. Now, make sure when you type this into your calculator, you need to put this, or you need to put parentheses around the numerator and parentheses around the denominator. I didn't mean to put that. Well, because tangent, you need to have one. I'll give you a second to figure out what A is. So the measure of angle A is equal to, and let's round to the 100th. Round to the 100th. What did you guys get? 11.82. Good. All right, so angle A is 11.82, but is that my bearings? No. So what do I need to do from this? So in your calculator, you have this long decimal. Just hit minus 90. You're going to get negative degrees, but we'll just take the negative off because remember, A and my bearings is adds to be 90 degrees, right? So that's why if you just subtract off the 90 without rounding, take that exact decimal, subtract off the 90. What do we get for my bearings? 78.20. Huh? 1.8. Okay. So now, what is my bearings? This is north. What? Northwest. So it'll be north 78.18 degrees west. And there's my bearings. Okay. Now we still need to find what? Our distance. So we can do our distance a couple different ways, can't we? Yes. We can either use the 11.8 and do the opposite over my hypotenuse, right? Or could I use Pythagorean theorem? Yes. Does it matter which way? No. What way would you like to do this? Pythagorean theorem. So my B is 20 sine 36. And what do I have to do with all of that? Square it. Plus, what is my adjacent side or my other leg? 20 cosine 36 plus 40 squared will equal c squared, right? And then what would I have to do at the end of that? Square root it, wouldn't I? So how do you type that in your calculator? So I'm just going to do parenthesis 20 sine 36 end, right? Square it plus parenthesis. I'm going to change this. I'm going to put on eyeball 20 cosine 36 parenthesis plus 40 end it, square it. And I get this 3,294.42 or something, right? So now I need to take the square root of that. So I'm just going to hit second square root. And obviously you notice it disappears. Just hit the up arrow. And I'm going to pull up that entire thing. Did it not work? Hold on. Square root. Insert. Okay, so instead, after I type that in, I got that, I hit up, it didn't work, so I hit second insert, and I put the second square root in it. And so I had the whole thing. And I got 57.4. is what it should be. Okay. So do you have enough parentheses?
Yeah.
So c squared was 3,200 and something. So no, you did not type it in right. Okay. All right. We'll work on that. All right. And that would be nautical miles, right? Nautical miles. There we go. All right. Harmonic motion, last thing. A simple harmonic motion is when the motion can be described by a sine or cosine function. So think of a spring. When you drop it, what happens? It goes up and down, up and down, up and down, up and down, right? Okay. Isn't that kind of like your sine, cosine? Now, they get smaller. Your amplitude tends to get smaller as it slows down. But it's in that whole motion where we still have a period, we have a frequency, all of that fun stuff, right? Excuse me. The formula that we use is D equals A sine of WT or D equals A cosine WT. Remember, what's the difference between sine and cosine? Sine always goes through the origin. Cosine starts at its max or min, right? So if I'm standing up top and I drop a ball, that's going to start at cosine because I'm at my maximum height, right? If I start at base and then just kind of drop it, it would be at 0, 0, kind of where we start, right? When we look at this, okay, A is still my amplitude. So the absolute value of A is still my amplitude, how high and how low it goes. The period is found by 2 pi divided by W, and the frequency is W by 2 pi, okay? Write an equation for the simple harmonic motion, the ball described below. If you want the actual like pictures and all of that, it is on page 330. I think it's through page 330, and it has all of this mapped out for you guys, okay? I didn't want to have to draw all of that and print off more paper. But for example, consider a ball. We're just writing equation. So do we have to actually calculate anything really? No. All right. Consider a ball is bobbing up and down on the end of a spring. Assume that the maximum distance the ball moves vertically upward and downward from its equilibrium at rest position. So at rest position, so where it's sitting. So is that going to be sine or cosine? At sine, right? So we're going to use, for writing equation, we're going to write it in sine. All right, is 10 centimeters. So what does that 10 centimeters represent? The maximum, all right. So the 10 is our max, which is our amplitude, right? You guys okay with that? All right. Now, it could also be, obviously, negative 10 could be A, right? A could be also be negative 10 if I drop it first, right? Depending on where we're looking at. But we'll go from there. Assume further that the time it takes the ball to move from its maximum displacement, so the maximum displacement 10 above 0 to the maximum displacement below 0 would be negative 10 is t equals 4. So from the max to the min, it takes 4 seconds. So what does that 4 seconds represent? So think of a sine curve or a cosine curve, right? If I go from the max to the min, isn't that 1 period? So we know our period is equal to 4. You guys okay with that? Now, to be able to write our equation, I need to know A and I need to know W. Do we know our A? Yes, what's my A? Huh. Do we know our W? No, but I can find it, right? What do we know? We were given the period, and what do we know about a period? It is found by what? 2 pi over W equals 4, right? Can you guys solve for W? Yeah, how do I solve for W? Multiply it over, so 2 pi equals 4W, and then what? Divide by 4. So W would equal pi over 2. So now do I have my W? Yeah, which is what? Pi over 2. Did you write your equation? Yeah. Yeah, T's right there. No, that was just for our period, our time. This is, remember, this when we write an equation, we normally have an x and y in there, right? Our distance is our y, how high it is. Our time is our x-axis, right? And how far it goes at a certain time. So now from this, I can say, well, what's my distance when I get after 10 seconds, after 20 seconds, things like that, okay? And you're done. Did you write your equation? Example 7, consider the equation for simple harmonic motion, d equals 6 cosine, and I want this to be 3 pi over 4 t. Okay, let's change that to 3 pi over 4. Find each one of these. The maximum displacement. 6. Well, my amplitude is 6, right? Maximum displacement is my amplitude, which is 6. You guys okay with that? The frequency. How do we calculate frequency? Huh? It is W over 2 pi, right? Because period is what? 2 pi over W, the frequency is W over 2 pi, right? Well, what's my W in this problem? 3 pi over 4 divided by 2 pi. Well, do we know how to calculate that? Yes. Keep it, change it, flip it. We're just dividing, right? So isn't this the same thing as 3 pi over 4 times 1 over 2 pi? Yes, no? Yes. What happens to those pi's? They cancel. And what's 3/4 times 1/2? 3. So my frequency is 3/8. The value of D when T equals 4. Can I plug 4 into T and solve for D? Yes, without a calculator? Let's try. All right, so D equals 6 times the cosine of 3 pi over 4 times 4. What's 3 pi over 4 times 4? Yeah, 3 pi. Now let's think of something. 3 pi, isn't 3 pi the same thing as just pi? And if I'm looking at my coordinate plane, my unit circle, isn't pi right here? What coordinate is that? Isn't that -1, 0? So is cosine the x or the y coordinate? The x. So what's my x coordinate? -1. So what's 6 times -1? So my distance is -6. So that means it's actually at the lowest point of it, right? 3 pi? 3 pi is the same thing as just pi, right? So I just looked at it in that sense without a calculator. Now, could you type in cosine of 3 pi in your calculator? Yes, it would give you -1. Yeah.
Wait, so the cosine is just get to the point on the.
Well, 3 pi, well, if it's pi, 2 pi, pi over 2, those are like 90 degrees, 180 degrees. So with 3 pi, I just looked at 3 pi is the same thing as pi. So it's like our unit circle kind of remembering. Yeah, so I was kind of thinking on it as a memorization tool in that sense instead of using your calculator. Yeah. All right, the least positive value. So we're looking at positive values. So that's going counterclockwise, right? Okay. So do I have to look at like negative pi over 2, negative pi over 3, -4 pi? No, I'm going to look at all just positive values, okay? For which D equals 0. Okay, so let's plug 0 in for D equals 6 times the cosine of 3 pi over 4 times T. Real quick. How do I move 6 to the other side? Divide it. And what's 0 divided by 6? 0. So we have the cosine of 3 pi over 4 times T equals 0, right? Let's think about this. When is, and I'm not even worrying about this right now, when is the cosine equal to 0? At what values? Think of this. Is it at pi? Is it at 2 pi? No, but if I'm looking at this at 0, 1, 0, -1, is my cosine 0? Yes. So where is this? This is at pi over 2, isn't it? Where is here? Where's 0, -1 at? 3 pi over 2. If I went around again, that would be 5 pi over 2, 7 pi over 2, and so on, right? At every y-axis, wouldn't I, or every 90 degrees, and then 180 from there, aren't we at 0, cosine being 0? Yes. Okay, so the cosine of any one of these values is equal to 0. However, we're taking this 3 pi over 4 times T, and it's supposed to be pi over 2, right? So let's think about this for a second before I actually solve this. The least positive pi value. Which one of this is probably the least positive pi value? Pi over 2, because it's the smallest, right? So let's go ahead and set, and we're going to check. So we need 3 pi over 4 times T to equal pi over 2. Can you guys solve for t? Yeah. How do I solve for t? Multiply by 4 over 3 pi, right? Okay, so t would equal, pi's cancel, 2 becomes 1, 4 becomes, so isn't t equal to 2/3? So if I say 2 is 2/3 and I plug it into t, I would get pi over 2. And isn't the cosine of pi over 2 equal to 0? Yes. Okay. Now let's check the next one just to see if 2/3 is the smallest. Let's plug in 3 pi over 2. So 3/4 t equals 3 pi over 2. So again, we're going to multiply by 4 over 3 pi. What do we get for t here? Just 2. So isn't 2/3 my smallest value? So at 2/3 seconds, as we're in seconds, at 2/3 seconds, we will have the smallest positive value for which d is 0, our distance is 0. Okay? And then as it goes. Now, again, we didn't use negative pi over 2. Why? Because it wanted the positive, right? All right. Any questions on this?